Assalamualaikum dan selamat sejahtera semua. So dalam video ni saya akan bagi skema jawapan untuk Prelab eksperimen 3 energy. Okay. So kita terus ke soalan nombor 1. State the law of conservation of energy. So for the closed system, the total energy is constant. Okay. What is the meaning of closed system? Closed system means there is no external force. Okay, total energy constant means total energy initial equals to total energy final. Okay, number 2, state the gravitational potential energy and kinetic energy. Gravitational potential energy is energy of object due to the position or height, and kinetic energy is energy of object which is in motion. When the object move, so the object have kinetic energy. Number 3, what is the symbol and SI unit of gravitational potential energy and kinetic energy? Okay, gravitational potential energy symbol is UG, or you may write as U. Okay, and symbol for kinetic energy is K, and their unit are joule. Okay, joule. Okay, question number 4. Based on the situations below, answer the question. Okay. Situation A, object at h 10 meter from ground, and situation B, object at 5 meter from ground. Alright. A, using the conservation of energy, determine the velocity of the ball just before it reached the ground. Okay, velocity of the ball just before it reached the ground. Okay, so you may use principle of conservation of energy. Total energy initial equals to total energy final. So energy initial when object at position A, so it has potential energy U, and when it reach the ground, before it reach the ground, it has kinetic energy. Okay, because it still move just before it reach the ground, but it has no potential energy because it is at ground level. So formula for potential energy is mgh, and formula for kinetic energy is half mv squared. Then you can cancel the m. Okay, can cancel the m. Okay, and then simplify. Let v be the subject. Okay, because we want to find the velocity v, so v equals to 2gh square root. Okay, so substitute g 9.81, substitute height. Okay, height is 10 meter, so velocity before it reaches the ground is 14.01 meter per second. And then for situation B, it is the same. It is the same concept, but for situation B, it is at height 5 meter. Okay, so just substitute h 5 meter. Then you can determine the velocity before it reached the ground. Okay, it is 9.9 meter per second. Okay, B, from the answer calculated in question A, what can we deduce about the relation between the release height and the velocity of the ball before hitting the ground? Okay, velocity of ball is directly proportional to the release height. Okay, the higher the height, the greater the velocity. Okay. Okay, situation A, h is 10 meter, velocity is 14.01 meter per second. Okay, for situation B, height 5 meter, the velocity only 9.9 meter per second. Okay, look at question number 5. What is the energy owned by the ball bearing when it is attached to the free fall adapter? Okay, so it has gravitational potential energy because it is at particular height. Okay, number 6, what is the usage of the photo gate? So the photo gate used as velocity detector. Okay, number 7, state the change in mechanical energy in this experiment. So the gravitational potential energy convert to the kinetic energy. Okay, number 8, state the related variables that need to be recorded in this experiment. Okay, manipulated variable is the falling distance h, and the responding variable is the time required for the ball to travel through distance s. Number 9, how the final velocity of ball bearing is determined. So you may use v equals s over t because we make an assumption that velocity is constant. Okay, velocity is constant. So when velocity constant, you can use v equals to s over t. Okay, then question number 10. An equation for a straight line graph is y equals mx plus c, where y is the quantity on the vertical axis and x is the quantity on the horizontal axis, as shown in figure 1. Okay, the velocity of ball bearing v is related to the height of release h by the following equation: v squared equals to 2gh. Okay, where g is the acceleration due to gravity. Based on the equation 1 and the graph, determine the variables for x-axis and y-axis. Okay, so you have to plot graph of v squared against h. V squared against h. So compare with y against x. So y-axis is v squared and the x-axis is h. Y-axis is v squared and x-axis is h. Okay, height h. Okay, so from the graph, what does the gradient m represent? Okay, so for this one you have to compare like this. So the equation is v squared equals to 2gh. You have to compare with y equals mx plus c. Okay, so y-axis is v squared and the x-axis is h. So the rest is m equals to 2g. Okay, m equals to 2g. So m here equals to 2g. M equals to 2g. Okay, this one m equals to 2g. And then see from the gradient of the graph, how can we determine the value of g? So let g be the subject. So g equals to m over 2. Okay, gradient over 2, where gradient you can get from y2 minus y1 over x2 minus x1. Okay. Okay, number 11. List 3 precautions of the experiment. Okay. First, the photo gate is placed exactly parallel to the free fall adapter and the table. Second, all connecting wires are connected properly to the right terminal of the timer, photo gate and free fall adapter. Third, the trigger of free fall adapter must be pressed centrally to avoid undesired impulsive force on the ball bearing. Fourth, the fan is switched off in order to avoid the wind and air resistance. And fifth, the contact between the observer and the table is avoided as less as possible. This is to prevent the vibration on the apparatus. And sixth, the ball bearing is ensured to move in the straight line passing through the photo gates. That's it. Thank you, class.